Hello, so today we are doing this problem called add two numbers. So the problem says we get two non-empty linked lists that represent two non-negative integers, and the digits are stored in reverse order. So for example here 342 is stored as 2 as first the head of the linked list, followed by 4 and 3. So you can see that's the reversed order. And the goal from the problem is to add the two numbers and return a linked list result. And we may assume that two numbers do not contain any leading zeros except the number if the number is 0. And so you can see here we have 342. It is represented as this, 456 represented as this. You can see it reversed, and the sum of these two numbers is 807, which is represented also. We want to return it represented as a linked list. So that's the problem. How can we solve it? The first thing to notice is that, well, we can just convert the linked list into an int and convert this one also L2 into an int, add them up with normal integer addition, and then convert that number back into a linked list of this format, right? So that's pretty straightforward. I mean, there is like, let's say the length of L1 is n, and then the length of n1, the length of L2 is n2, then our time complexity of that solution would be of n1 plus n2, right? And the space complexity wouldn't be much, right? We would just be using one extra space for this one and then the space for the result, right? So the space would be whichever one is bigger. Like we may have a linked list where this one contains 4 elements and this one contains 2. Let's say we are adding 222, 200. Let's say we are just adding 200 to 100. So the length of L1 is bigger. So the space complexity would be at most whichever one is bigger, right? So max of n1 m1, right? So this would be the complexity of our algorithm that does this conversion. And so let's try it out. So the first thing we need to do is convert it to an int. So to int, let's say we get a node, and we're going to convert it to an int. And then we will need something that converts to a list, so that it can convert let's just call it a list. So that it can convert the result number here to a linked list, and that gets a value, right? And then our final result would be just using these two. So we will add the two elements, the number, convert L1 to an int, convert L2 to an int, and then just convert the result to a list, right? So that would be our solution. So let's code up the two int one. So to use that one, what do we need to do? So we need to just take the node value multiplied by 10 and then add the recurse on the next, right? Node.next. That's pretty much it that we want to do, right? Sorry, actually, so this would work if the linked list wasn't reversed, but the linked list is reversed. So what we need to do for this one here to convert it to an int is, say we want to do first we are at node this, so that's 2. Then we are at node 4, and then at that point what we want is, so let's say it's x is the sum, right? Then here x should be equal to 42, right? So that, and then we add 300, so we want 42, so we want 4 multiplied by 10 plus 2. The 2 is the previous x, so that's, so, and this is node val for the pointer is pointing at this node, right? And then when we advance again, so this would be 4 multiplied by 10 plus 2, yeah, so that's 42. And then when we get to node to be at 3, we want node.val multiplied by 10 again plus x, so that would mean multiplied actually by not 10 but by by 10 and then by another 10, right? So by another 10, so that we can have 300, right? plus 42. So that we can have. So what I'm saying is, with the recursive function, we need to multiply by 10 so that each time we recurse, we can multiply by another 10. And so that would mean we need, in the recursion step, we need to have, this is the smaller input size, and then the operation we need to do is multiply by 10. And then because of this, we will, for this case, we will multiply by 2 because we will go 2 levels deeper in the recursion. And then we need to add node.val, which is what we are doing here for this x, right? But what is our base case? So our base case is if not node. What should we return in that case? We should just return 0, right? But we can simplify this and say to int node if we have a node, right? Otherwise we can just set 0, right? Else 0, and then we don't need this anymore. Now let's do the to-list solution. So to convert to a list, we just need to first, we're going to use also a recursive function. So the node would be, we would have list node, right? And we will have node, the value n modulo 10, because if it's 11, then we want, or let's say it's 12, the n is equal to 12. We want to put 2 at the node and then recurse so that 10 can be also, we can put 1 in front, right? If we have 123, we want to put 3 here and then recurse on 12, right? And so that would be the first node. And then we need to do node.next, right? Which would be equal to converting for the remainder, which for the rest after we get that 10. But the thing is, we don't need to do this if n is less than 9, right? Because if n was less than 9 or less or equal to 9, then we would have, this one is enough, right? Because the modulo is the same value. So this needs to happen only if n is bigger than 9. And we add the next. That's 2 would be the next, and then we can just return node. And that's pretty much it for the solution. So let's run it. I should probably close this once. Okay, so looks like this is working for this case. So let's submit and see if this passes. Okay, so that solution passes. There is another way to solve this problem using a carry, where we can just iteratively, so basically instead of converting to an int, we can do it by just traversing the 2 linked lists and keeping the carry, so that we can add it to the next one, which is also straightforward. So we can try that one out. And yeah, that's pretty much it for this problem. See you next time. Bye.